Hello everyone, welcome back to the session, grade 10 physics, chapter number 13, magnetic effects of electric current. Magnetic effects of electric current, part C we are continuing. In this part C, students, we are going to discuss about force on a current carrying conductor. Force on a current carrying conductor, Fleming's left hand rule and electric motor. These are the things we are going to discuss. So what do you mean by force on a current carrying conductor in a magnetic field? So here, when a current carrying conductor is placed in a magnetic field, you have a current carrying conductor. Means a conductor in which current is passing and that is placed in a magnetic field, it experiences a force. This force acts perpendicular to both. How the force is acting? The force is acting perpendicular to both the direction of current and the magnetic field. It will act perpendicular to both the direction of current and the magnetic field. See, magnets creating a uniform magnetic field. Electrons move through the copper rod. Copper rod will experience a force when current is switched on. So what are the factors that affect the force? The magnitude of the force will depend upon strength of magnetic field, how much amount of current is flowing, and how much is the length of the conductor inside the magnetic field. The magnitude of force will depend upon how much is the strength of magnetic field, uh, amount of current flowing, and how much is the length of the conductor inside the magnetic field. Direction of force. The direction of force depends upon direction of the current and direction of the magnetic field. The direction of force will depend upon two factors. What are they? They are the direction of the current and direction of magnetic field. This can be determined by using Fleming's left hand rule, what we have studied in the earlier class, and again we are going to continue with Fleming's left hand rule. In Fleming's left hand rule, students, you need to stretch the thumb, the forefinger and the middle finger of what? Of your left hand. I repeat, in Fleming's left hand rule, you need to stretch the thumb, the forefinger and middle finger of the left hand so that they are mutually perpendicular. All the three must be mutually perpendicular to each other. The forefinger will represent the direction of magnetic field, middle finger will represent the direction of the current, and thumb will represent the direction of force. See the figure here. And there is the easy trick, FBI. FBI is the easy trick. F stands for your forefinger, that is your magnetic field. B stands for the thumb, that is the motion of the force, and I stands for your middle finger, that is the current. Check the figure, and the easy trick to remember the Fleming's left hand rule is your FBI. And next comes your electric motor. So what is an electric motor over here? Electric motor is a device that converts electrical energy into mechanical energy. Electrical motor is a device which converts electrical energy into mechanical energy. So what are the principle of electric motor? An electric motor works on the principle. What is the principle of it? A current carrying conductor placed in a magnetic field will experience a force. So when a current carrying conductor, if it is placed in a magnetic field, what it is going to experience? It experiences the force. This is a principle of electric motor. So how are you going to construct an electric motor? Check the figure, the left hand side and right hand side. The main parts of the electric motor are, you need to have a strong magnet with north pole and south pole, the armature ABCD, split rings, commutator, carbon brushes, DC battery and axle shaft. So these are the parts which are required for the construction of an electric motor. We have sorted out the working into simple steps. The working of an electric motor. So when the current is on, switch is on, the current will flow through the rectangular coil, the armature ABCD. Then by the help of the magnet, the magnetic field will exert equal and opposite forces. From where? On the opposite sides of the coil. The magnetic field will exert equal and opposite forces on the two sides of the coil. Then the coil will start rotating. After every half rotation, students, the split link that is the commutator, split ring commutator reverses the direction of the current. After every half rotation, the split ring commutator will reverse the direction of the current, and this direction of the direction of the force also reverses. When the direction of the current reverses by the split ring, then the direction of force also reverses. The coil continues rotating in the same direction, producing continuous motion. The coil continues rotating in the same direction, so it produces continuous motion. So what is the role of split ring commutator? It will reverse the direction of the current when every half rotation, and it ensures, what it ensures? Continuous rotation of the coil. Continuation rotation of the coil. So where do I use this? What? Electric motor, electric fans, mixers, washing machines, water pumps, vacuum cleaners, electric vehicles, toys, and industrial machines are based upon electric motor. So what is the difference between motor and electromagnet? That is your electric motor and electromagnet. That is your electric motor and electromagnet. Electric motor will convert electrical energy into mechanical energy, and electromagnet will produce temporary magnetism, which will electric motor will produce as motion, electromagnet will produce magnetic field. Electric motor uses split rings, electromagnet uses soft iron core. Any students, anyone, any doubts, you can use the numbers, the WhatsApp numbers, or you can use the comment section and you can pass on your comments so that we can reply and respond to your queries. So we have come to an end of for this topic. Meet you soon with the next part, students. Thank you. Take care. Bye bye.